in fact, you can open up an editor in cpp.sh and basically do some experiments. You can do it now if you want. So you'd like to declare a variable, right? So say int b, right? Or you can say float x, because these operators also work on floating point numbers. Remember, in C++, you can operators have specific functionality, right? You could have defined the plus plus operator to say it does not work for floating point numbers, it only works for integers. But it's not the case. The implementers of C++ said, these operators will also work for floating all numbers, basically. Okay? So int b, you can say float x, and then assign some initial values. Let's say 5, right? And let's say x equals 3.14. Okay, now you can print these values. You can say cout double less than plus plus b, right? And l. But you can stick in some annotation here. So b equals. Okay, right? Plus plus b. See what you get, and then change it. So here's the best way to learn computer science. Not like in those days when you have an idea and you want to test it out. It takes you a long time to actually test it out. You got to go back before the day that I learned computer science, right? But I was at the fringe because I could talk to my parents, I could talk to my, the older relatives, and I know exactly how they programmed or how they learned computer science, and I can see how difficult it was because they have to go punch in their code. They write a program and have to punch it into cards, into little cards where the holes say, there's a card and the hole in a particular position says whether there's an A or a B or a C in there, and your entire program is punched in the form of holes, and you take them to a card reader. Actually, you don't take them to card reader. You go to your computer center, which probably has the equivalent of a PC XT or something in the back somewhere, okay? And you give them your bunch of cards, right? A stack of cards, which has your program in it. It's like a 15-line program, which you do right for breakfast these days, right? So you give them the stack of cards and say, here's my program. I want to see the output. And they'll say, okay, I got your program. Here's a logbook. You can come back at 7:20 a.m. tomorrow and pick up your output. Okay, so that's how much effort it took. That if you had some program that you want to try, to actually try it out. But now we have the luxury. I don't want to say we're spoiled, but we have the luxury of going from thought to reality in a fraction of a second, just like that. In most cases, right? And that's where we're going. Eventually, we will be in a situation, a utopia, where humans don't have to do any effort at all, because that's where we're going, right? I mean, with software and machinery and automation, what are we trying to do? We're just trying to make our own lives easier, right? And people initially complain, saying, hey, all the machines are taking over our jobs and shit like that. But really, that's what they want, right? They want to sit around and have the machines do everything for them, right? That's what we want. So, and that's, slowly and subtly, that's where we're going. And eventually you can imagine a future humanity where we don't have to do any shit, right? We just sit down in our sofa or be dreaming, right? And the computer is doing everything for us. Okay, just making us feel happy, So, but that's, we want to keep automating as much as possible so that we can do the more interesting, juicy, creative, imaginative things. So that's where we're going. And where was I going with this? So yeah, in those days it was so hard. And now, if you want to know, hey, what's the difference between n++ and minus, plus plus n? Just whip out cpp.sh or whip out a browser. Go to a library anywhere, right? Or on your phone. You can do it on your phone too, right? You go to whip out a browser on your phone. Go to Chrome. Go to cpp.sh. And say on a bus or in a train or in commuting in a Tesla, so you can actually do your coding as well at the same time while you're driving, right? Okay, then you program your Tesla to take me to Foothill, and all right. So you can code on your phone and say, hey, I want to see what the difference is between n++ and ++ n. So you can just whip it up and say, all right, print n++ or print ++ n, and then see the difference between the two outputs. So what I mean is that this is a very useful dictum to keep in mind. Today's computer science, but generally, when in doubt, try it out. Okay? It doesn't take you any time. Unless that's the thing, right? Because there is so much today that's available to us that is just not being used because people are not aware of it. So, like I said, in Foothill, there are so many things that are free to students, right? There's so many facilities, food, right? This is food, right? This is a free food pantry. Anybody's hungry, they can just go get food, right? And so many things available, but how many of you knew about this, right? So, yeah, you knew, because you're sitting in the front row, you're the closest to this, right? So you know this, right? Yeah. Okay, yeah. So, but the thing is, a lot of these features and facilities are not, we don't know. And because we are, living in a world where many of these computing facilities too, right? The features of computers that are hard, we don't take advantage of that luxury. The luxury of being able to test out your experiments like that, which didn't used to be the case many years ago, and it's there now, but people just take it for granted. And you take something for granted, you're not going to use it, right? So only when you don't take something for granted and say, wow, oh my gosh, I could not have had this, right? I could have suffered so much without it, then people will say, oh, that's really valuable, I want to try it out, right? If something has no value, you're going to say, I'll come back to it later. Isn't there a saying that people who live in the Vatican never see the Pope or some stuff like that? Okay, because he's just next door. You can see him on the way to Trader Joe's and say, hey Pope, how you doing, right? So you can't do that if you're here. So people go all the way from other countries and there to say hi to him. So that kind of thing. So take advantage of all these things. So find out what's available that you can do in this computer. Go ahead and do it. And so the point I'm making is experiment. Cut code all the time. Always be coding. That's ABC, right? Oh, that's much better. What did I say last time? Always be something else, right? No, I don't mean always be something else, but always be closing is more in line with Alec Baldwin's code in that film, ABC. All right, so let's. So what do we want to do? Do you guys want to do an experiment on your own? I can come around and help. People can help. So where you want to write a program, a simple program, like 10-line program, 5-line program in main, you assign a variable, a value, and then print out the value using a plus plus before the variable, use a plus plus after, okay? Let's first find out and nail down in our heads exactly what happens. So it needs to be completely internalized to say when the variable gets incremented, when it's decremented, and so on and so forth. When that's ready, you will be all set to use that construct in your looping and in while loops and for loops. So let's take about 10 or 20 minutes for you to just experiment and write some programs. Here, let me do a really quick shell of the program. I'm not going to open my laptop just yet because I need my reading glasses. But I'll just write on the code because I can use a font that's as big as I like. Okay, so if you want to do something like main, forget about parameters. For main, you want to say int b equals, I don't know, give it some value, 10, right? And you can try float also, right? This is the same. Float x equals 3.14. Now, one of the things you might note about these naming, it doesn't matter to the compiler whether I say, int x and float b. I can do that, yes. It's all the same as far as the compiler is concerned. But it's not the same as far as humans are concerned. Why? Right? Because as humans, we're kind of conditioned from a very young age when we do mathematics to, think of x, y, and z as real valued variables, right? They're on the continuum. Whereas a, b, c, i, j, k, what are you used to thinking of them as? Integers, right? So when you're programming, although it doesn't make any difference to the compiler, and once you compile your code, nobody's going to know the difference, right? Because these are going to get changed to internal, memory locations. But to fellow programmers who read your code, especially the good ones who tend to have a good, a reasonable mathematical background too, you can be kind to them by using their existing, leveraging their existing notions of what variables and need to look like. So don't use x, y, z for continuous, discrete valued variables, because you have so many other letters. So use a, b, c, right? I, j, k, n, m. Those should be your integers. And then if you're using real valued variables, use variables like, x, y, z, Jasmine, thank you for coming, okay? X, y, z, I don't know. This is only 3 real valued numbers I can think of. Well, you didn't think of other ones, but that kind of thing. All right, so you got these integers. Now you can say, cout, well, you got to do a standard cout, right? Or you can say using namespace here. All right, cout double less than b equals, and then you say plus plus b, right? And then you want to put the and L here. So you can do that. Now compile it and run it. But before you run it, so here's a trick, right? So every time you write a simple program like this, don't click run before you click run in your mind. I think that usually helps a lot. So after you write the code, in your own mind, run it and say, this is what I expect the output to be. So in this particular case, what do you expect the output to be? So the plus plus before a variable simply means that, the first thing you do before you evaluate the expression, that expression, this entire expression here, right? So before you do this, increment b, right? Whereas if I had the plus plus after the b, that means evaluate this expression first, but increment b before going on to the next line. Now, you see, that's a very subtle change, isn't it? It's a very subtle thing there. And because it is so subtle, if you goof up, if you make any mistakes, or even if you have typos, it could cause subtle errors in your code, right? If something is big and you make an error there and it craps out and your program dies, you're lucky because your program just didn't even run, right? A program that doesn't even run when you try and run it, and you're trying to debug it, you're lucky because that opportunity, that chance to debug it, it's not going to be difficult because it doesn't run. But these subtle errors, which you will start encountering more and more from lab, quest number 6 onwards, right? So that's quest number 6. Will have you'll have more logic built in, right? When you're trying to encode the logic, you'll have more chances of going wrong. But the program will actually run, but it won't do what you expect it to do.